I'm just really excited that a group like this exists on campus. I think this is just really terrific. Let's see, so I'm in the art department and also in the games and simulation program. I'm an electronic artist. I do a lot of code-based artwork. I do programming and 3D modeling and animation and like drawing with charcoal and performance art occasionally and some music, kind of like a whole mix of different things. A large part of what I'm interested in is using computer code as an expressive medium, as an art material, in the same way that you would use paint or clay or film or anything like that. I'm also very interested in virtual reality, in immersive simulation, in sensory immersion as an art form, as an art medium as well. And that's one of the main projects that I'm going to talk to you about today is ways of making this powerful technology more accessible, more usable, cheaper, kind of unlocking a lot of potential that it has that's kind of been, not fully explored over the last really 20 or 30 years that it's been around. But maybe before I get to that, I'll do a little bit more explanation about where I'm coming from. So this is my website, which is very, you can only see part of because the resolution's all messed up on here. Something with my graphic settings. Anyhow, maybe I'll show you this piece first because it's funny and I feel like I ought to because I'm the gaming professor. Can I turn these lights down? Is there a button on here that does that?
I think right behind you.
Oh, okay, thank you. Yeah. So this is a game that I made called Philosopher Deathmatch, and we'll go kind of quickly through this so that I don't spend a whole lot of time on it. But you probably are all familiar with. You can recognize that this it's quite free. I mean, that's Ludwig Wittgenstein, Martin Heidegger, Friedrich Nietzsche, Aristotle, Bertrand Russell, Jeremy Bentham. So there's a whole variety of different philosophers that you can play as. So, this is kind of my interest in games in one way is this idea about game, the underlying structure, the mechanic of games, and what else a game can represent with the same dynamic system, right? It's combat and philosophy, are really
philosophy is the best.
Yeah, exactly, right. So when you see all in the chat window up there, they argue while they're fighting as well. So so you have kind of like positivism, and you have the theories of ontology, and I think there's objectivism in there somewhere. There's a lot of sort of argument about the nature of being, which I felt was really appropriate for a game where it's mostly about being and then rapidly not being, and then being again. So anyway, that's a Quake 3. It's a Quake 3 mod. This is one of the things that I'm kind of interested in is these kind of teasing out these collisions between games and art and different kinds of conceptual provocations and things like that. This is a piece that's not really as silly, but is kind of neat. It's called Sympicology. It's a virtual reality environment, actually a multi-user network virtual reality environment. About creating collaborative sound sculptures. And the way it works is you have this big stereoscopic projection screen right here, and there's a motion tracking interface and the 3D glasses that you wear, and you get transported to this virtual island, this beach, where these little puffballs, these seeds come drifting in over the water. water, and if you grab them and plant them in the ground, then they grow different kinds of plants and caterpillars and rocks and crystals and things like that. And all of those contain sounds, which are spatialized in a multi-channel kind of localized audio system. So you have this immersive image and then also immersive soundscape around it. It's a networked cave system, so you have multiple VR setups like this with people in different cities collaborating together to build this kind of garden of different audio experiences. This is another virtual reality environment. I think a lot about the nature of simulation and about artificiality and about things that we create in these virtual worlds and games that are that are simulations of things, and then also the things that we have around us in our everyday lives outside of the computer, which are also simulations, like IKEA furniture, for example, which is kind of like this simulation of real furniture. And it's, IKEA is really neat because it has this modular sort of idea that each one of those things is this little unitary grammatical building block that you can then recombine together in all these different ways to make this customized living space. And I got sort of thinking about extending that to the actual furniture pieces themselves. So what happens if you are allowed to really recombine all of the pieces of the IKEA themselves? There are these different genetic strains of IKEA. So there's one sort of kind of IKEA that's this sort of like Scandinavian rustic, and then this other strand that's that there's this very sleek modern style, and then another one that's kind of like a French provincial style. So what if you start to interbreed those things as if they were genetic code? So I made this thing that's an IKEA furniture mutator, where you get these little pieces of wood and stuff and you stick them down into the ground, and then you combine with other pieces and it grows like a chest of drawers or a bed or a desk. And then as you keep moving them around in this room, so you get this gigantic, beautiful loft space that we get to decorate initially also. And as you move them around, they kind of mutate more and start kind of turning into like constructivist sculpture. That's like these abstract things at the end. That's kind of like the ultimate evolutionary goal of all IKEA is to become abstract sculpture. This is just another piece. This one's sort of this is old. This is a robotic piece or a kinetic sculpture piece. That I feel is like kind of I don't know, like kind of relevant for this environment because so many people here are doing like really good research on computer vision and security and things like that. So you can see it's this security camera on our motors that has some sort of like basic motion face tracking software in it. But what it does is instead of following people, it tries to avoid you because it's insecure. And so it has this kind of like real nervous quality to it. And if you try to stare at it, it'll kind of freak out and look away, and it gets really scared by sudden movements and that kind of thing. So anyway, so these are the kind of things that I make, and like the VR stuff is probably the main thing that I'm interested in. But there's also all these other kind of things having to do with interactivity and space and like bodily experience and sort of like changing the nature of technological artifacts and turning them into new things that I'm really interested in. So for me, the connection to open source for you guys, where does this fit in? Over the years, doing all these kinds of work, I've started to gravitate more and more towards open source tools as much as possible for a number of reasons. One of them is just philosophical, that I just think that they're important and beautiful just for themselves. One of the reasons is just practical, that a lot of the times there's an open source thing that is the tool that I need to do a given project, and like there is no commercial analog out there. One of the really big reasons also is just longevity of work. One of the things that you run into a lot creating artwork and also other kinds of similar artifacts is the need to have them last for a long time. A lot of times if you're making, like, let's say games, which is like what I'm into now, you think maybe like a year or two as your like support cycle for something, right? It's just about what the technology is right now, getting the thing out the door, getting it like as many copies of it sold as possible. You know, you don't really worry about maintaining it 10 or 15 years on down the line. But art, you do. You're thinking on this like 20, 50, 100-year time span of wanting the work that you're creating to continue to exist. And one of the important things is being able to have like a software platform that can continue to exist that long, or that can continue to evolve that long. The killer for me was this program called Macromedia Director. Any of you guys ever use this thing? Ever heard of it? Yeah, a few people have maybe heard of it. No one cares about it anymore. It's like totally irrelevant. Or you can put that on the web. People still use it. It still has its place. But it's like this sort of like heartbreaking thing, because I dedicated like nearly a decade of my life to that thing. It was my main tool, and then it just kind of like fell off the radar. It stopped being supported. It stopped being updated. Can't really be used anymore. So I have these artworks that were made with it, and I can't show them anymore because I can't find an old enough computer and an old enough copy of Director 7 to install on it to put the program on, and because the whole thing is proprietary, the application and the file format and everything, I'm stuck. Like that stuff just like it gets sealed away in a little time capsule, and nothing can happen with it anymore. The insecurity camera is an example of that. We made that with Director originally. We eventually had to remake it using pure data because we couldn't show it anymore using the Director version. It just was impossible. We had to throw the whole thing out and start over again from scratch with pure data and an Arduino. So there's practical reasons, there's philosophical reasons why I think this is, why I think these issues are really important. I won't go into it too much right now, but there's a group called Go210, which is a software art collaborative. They published a book called Floss Plus Art. There's a whole series of essays on the connection between contemporary media art and Libre and open software, which is a really interesting read you guys should check out. And of course, we have these wonderful things like processing, like open frameworks, like pure data.
Yeah, the processing is used for the ground zero name placement. They use the processing software to display the names.
Oh, that's really cool. Yeah, that's neat. Like the Arduino, which is open hardware. So like these are things which are totally revolutionizing what it means to be a digital artist today. Because digital artists, we grew out of a kind of culture of Photoshop and 3D Studio Max, and like a few like commercial audio programs. And this is kind of like the world of like the 90s on of what digital art was, what your tools were. And like this whole ecosystem of open source software, of being able to do these incredible things with completely free tools is incredibly liberating. And it's opening up this whole new wave, this whole new world of media art possibilities. But let me just go back to the VR stuff. This is the problem I've been thinking about a lot lately. So immersive environments, the stuff that I'm talking about are things like caves, these multi-wall stereoscopic projection systems. This thing on the left is called the Star Cave at University of California, San Diego, which has something like 36 stereoscopic screens in this eggshell kind of configuration. It's basically like being on the holodeck. Like that's what this is. I think that that and the idea of the holodeck kind of emerged around the same time. I'm not sure exactly which one came first. But these are incredibly expensive. So that thing like on the right over there, that kind of cave configuration, you can buy one of these. You can go to a company called Mechdyne. You can pay about $500,000 or $600,000 for one. That's it. And they have proprietary custom software solutions that they will develop for whatever your application is, whatever your visualization or simulation training application is. So it's like a big budget player kind of a game. Most of the immersive display things tend to be in that kind of category. And there's a whole lot of applications that get left out in art and digital humanities, a lot of entertainment things, a lot of research possibilities that simply don't really get to be explored because the technology is so expensive and so inaccessible. And this has been an issue with virtual reality really from the beginning, and it really still is. However, this is a really good moment because a lot of the enabling factors to make that really change have now come to pass. So the things that I'm talking about are stuff like virtual art. This is a woman named Shar Davies who made this piece called Osmos. This is in like 1994. It's really, really old, but it's this full body immersion, head mount display kind of poetic, abstract, artistic experience. These two images on the top are from a project that I'm, a group of artists that I'm working with on a reconstruction of the concentration camps during the Holocaust. This thing down on the left is an archaeological site reconstruction. On the lower right is an example of digital cave writing, taking literature and turning it into a fully immersive, like new kind of an experience. One sort of like possible hypothetical case study for doing something with VR. Imagine a museum of Himalayan art. I happened to like hear about one recently, so that's why this is in my head. But like Himalayan art is something that's like very rare, it's very fragile. It's something that's very hard for us maybe to understand outside of the context of where it came from, right? So to be able to make a museum of Himalayan art would be really nice if you could actually experience being in the Himalayas, being in Nepal or in Tibet. And if you could really manipulate, interact with these everyday objects, the artifacts, in some way. But you can't do it the real ones, of course, but if you made a VR environment, you could. And so things that you would need in order to do that, you'd have to have a good intuitive interface, you'd have to have a really good, high-quality, immersive set of visuals, but the thing would have to be affordable, it would have to be like kind of robust and easy to maintain, and it would have to have this kind of longevity to be able to exist, because, I mean, this isn't like an NSF project or something, it's like a Himalayan art museum. So they have to be able to keep this thing running and have it be like a part of their place. Am I going a little long?
It will take 5 more minutes.
Okay. Okay, so this is kind of the thing that I'm interested in, is taking this technology that's very powerful, that's very compelling, that can create these amazing experiences, but is mostly really out of the reach of a lot of the people who can really do interesting things with it, and try to bridge that gap a little bit. How does a cave work? How does a VR system work? Back in the day, you'd get 2 SG Ionics supercomputers, things that are like refrigerator size kind of things, and you'd use all this, like fairly intense kind of hardware. The same is really true today. It's, the names are a little bit different, but the equipment still tends to be very expensive. But there are really cheap ways that you can do this as well. Right, so you can use really just like a gamer PC has this power that's way beyond what an Onyx is, from 10 or 15 years ago. You can use just like video projectors that you buy on Amazon, that you get out at Staples. Motion tracking has always been this really expensive part of the system. This is like $10,000, $25,000 for motion tracking systems that you would have traditionally in a cave. Now you have the Kinect, which is $150. And so there are all these like massive jumps, like orders of magnitude jumps in the underlying technologies that make up the VR system, going from this extreme high-end research, military, like oil exploration, medical research kind of sphere into the consumer entertainment sphere, right? And so there's like possibilities there that we've never had before. This is just a price breakdown on hardware. In 2001, building just a single wall stereoscopic display system, a thing that's often called a geo-wall because it's used in the geological sciences community a lot. You look at the cost of these things. The projection screen is $10,000. Today it's like $1,400. the Flock of Birds Ascension magnetic tracking system was like $6,000 to $9,000. Now a Kinect is $150. So there's this huge shift. Even at what was the very low end, the cheap VR of the day was like a $23,000 to $25,000 system. And now, just hardware-wise, it's significantly less. All right. So now here's the point. We've got this, this great change in what's available with hardware. Has that happened with software also? The way that we make virtual reality environments tends to be with these fairly expensive proprietary commercial engines. Some of these are game engines, things like the Trinity engine, the Cry engine, Virtuals, which is kind of like a serious game simulation / game engine thing. Stuff like Conduit, which is like one of the main, well, probably VR applications where you take your CAD or Maya software, Autodesk Inventor, whatever, and you plug that directly into the cave. So the cave just becomes the visualization display for your CAD software. But like, where are the open source options? Where are the inexpensive options? Like where's the options for the average person to go and build a cave in their living room? And there's some great starting points here. We have a lot of terrific open source free game engines, but there are a couple of important limitations that are kind of like the stumbling blocks that I'm seeing. One of them is that a lot of those are like C++ APIs, right? So like Open Scene Graph is this terrific thing that you can use to build multi-wall VR systems, but it's all in C++. I think that's kind of like all you can do with it. OpenSG is kind of the same way. They're slowly starting to build other language bindings onto them, but that's sort of this major barrier to entry for people to develop content with them. Ogre also the same way. And a bigger issue is probably just a visual editor. Even like any of these, Panda 3D is probably the easiest to use on that list that I've made right there, and it has no visual editor, so like everything is all done with code. These things, right here, the reason that you can rapidly develop things with them is because you have some kind of a scene layout application, and that doesn't exist for these guys. So this is the thing that I'd like to do, is basically take any of these, like probably Panda or OpenSG or one of those things, and try to develop a way to make that into a sort of standard, almost like plug-and-play platform for doing immersive VR. Visual Scene Editor are bolded and put at the top of the list, because that's also something that the indie game community needs. Because these are things that are used for VR, but they're also game engines. And this is also a component of those engines that's totally missing compared to other things like UDK and like Unity and like all these other like really good commercial engines that are out there right now. And then there's other things like in there about getting all of the VR stuff to work. These are all engines that you can do this. It's been proven you can do it with it, but it's kind of like abstract knowledge. There isn't like a thing like a template that you just sort of get. Plug it in, plug all your projectors in, bam, you have a cave. And it's kind of like low-hanging fruit. It wouldn't be that hard to get from point A to point B to be able to do it. But this thing, the scene editor, is probably the most important thing to make it into, make any of these into a viable content production sort of tool. Okay, I think that's about it.
Thank you. Can you put the slides, send the slides to me?
Sure.
Okay, good. I'll post it and put links to that so that students who are interested in some of these can pursue. Thanks. Thank you, Ben.